performance-based methods and measurements, and basically how to assess data quality. Performance-based approach has been around for, about 20 years now. It first came out with methods 30B and 30A that I had a heavy hand in. I'm just going to kind of go over some highlights, so for many of you this will be a refresher. So the performance-based measurement approach offers some advantages over the old way that EPA used to do things, which was the method 301 validation, with the quad paired probes and spiking and stuff, and it used to be specific to a particular industrial source category. So let me just quickly use method 29 as an example. Method 29 was validated using the old method 301 approach, where they went to municipal waste combustors. That's where they were going to start regulating metals first, and they did it. And it cost multi-million dollars back in the 1980s, and then they wanted to use it on coal-fired power plants. Well, they had to do that method 301 all over again, even higher costs. So the performance-based approach offers an alternative. Not that EPA doesn't have method 301, it's still out there, and as a matter of fact, it was recently revised. The good thing is that performance-based measurements are very well suited to regulatory compliance, and the most important thing is that each and every time you use a method that's performance-based, it results in data of known and acceptable quality. So that means it can be applied to various measurement environments. It's basically self-validating. What also is, it has some incentives to it so that you can be rewarded for doing good work and for improving measurement quality. So there are what are called measurement quality objectives that are basically the performance criteria or the metrics for the approach. So I'll talk briefly about these. So I know I don't have a whole lot of time. So selectivity. So here it's where is it going to be applied? What is the measurement environment like? What are some of the things that you need to consider? So performance-based approach includes spectral interference tests, matrix interference tests, matrix spiking tests, blanks, comparison to other methods. So it's really important that you're able to understand the measurement environment that you are wanting to apply this approach to, so that you can be aware of their weaknesses. Accurate, and this is really the most important one. So this is like, how well do you agree with the true value? And there are multiple approaches to this that are, some are building blocks like calibration. You want to know if you're calibrating just the detector or the entire system, how well do gases transfer through a system, and that fundamentally measurements are in a specific calibrated range. But what's really the foundation of the method is assessing the overall measurement quality, and there are really two approaches to that, and that is pre-sampling, standard addition or spiking, the pre-sampling of media, obviously prior to sampling, as well as dynamic spiking, which is a standard addition with continuous emission measurements. Audit samples are important where you can get them. Method 29 is a perfect example. One of the things that I did early on was got my hands on some NIST fly ash, coal fly ash SRMs, and then submitted that to the laboratory as blind, and you would be surprised at what that revealed. Precision, so you're assessing random error, repeatability or reproducibility. There are a number of approaches to assess precision. replicate measurements, matrix spike duplicates, the relative standard deviation. It's really applicable to continuous or instrumental analyzers. And for the standalone chemical methods, paired trains are particularly important. Folks really don't like to do paired trains. It doubles the cost, but it really can be important. It's integral to method 30B and is actually part of the data validation requirement. You must meet a paired train agreement requirement. I tried to require paired trains. If anybody out here remembers the old Ontario hydro method, I think it's like 8 impingers. Nobody wanted to do 2 8-impinger trains in the same duct and traversing. So, yeah, okay, I can understand how the practicality drives things. And again, replicate dynamic spiking.